Hello everybody. Thank you, Bianca, for your kind introduction. A warm welcome also from my side to all the participants. Ladies and gentlemen, my name is Philipp Weissel. I will have a presentation today about the setup of integrated control consoles. And we will use the example of a washing machine just to make it a little bit more concrete what we are talking about or what I'm talking about. Actually, the content of my presentation today will be divided in, let's say, three parts. One which would be, let's say, to clarify what we are talking about touch controls, consoles, and what kind of design concepts and control concepts we see behind this touch controls. Second part will be about technology for integrated control consoles, especially highlighting the in-molded plastic films and also showing a small cost breakdown finally for this technology. And at the end of the webinar, I will, let's say, somehow say some words about our technology, the multi-skin films, and about the company Plastic Electronic. This should not take too long, so please don't worry. It will not be a company presentation then at the end. The whole presentation will take about 30 minutes, and I think it's very important that we could afterwards also start a kind of dialogue. So please, as already mentioned several times, please post your questions that we can have a discussion or some answers afterward. Yes, so first I want to talk about some design requirements. When we're talking about touch control panels, then there are some requirements regarding the design of these control panels. Usually you would like to have some intuitive interaction areas directly on your device. These interaction areas should be seamlessly integrated into the device. Maybe they should be 3D formed or should have a curved surface. The surface should, of course, be touch friendly. And maybe you're thinking also about a kind of shy-tech concept. So concept hidden behind, let's say, a surface only popping up when you want to interact with it. So things like black panel effect or something which shows that the technology is not in the foreground, but it's something which is hidden and shy, let's say. So what we did is we came up, or not we, actually our designers came up with a design concept for a washing machine. We called it the water drop design. And the water drop design is especially dealing with a kind of central control element of a washing machine, which is this central wheel where you can choose the program and several options of the program. And our designers came up with the idea to have a kind of design like a water drop falling into the water, and would give this kind of concentric circles, and to use this for let's say control panel for the washing machine. So we called this water drop design, and it shows everything what we think the requirements are for washing machine control panels, like, again, seamless surface, 3D curved surface, intuitive touch interaction area, and so on and so on. But of course there are also some control requirements, especially when it comes to touch control. People have already a very clear picture in mind. So touch control had to be, or has to work like an iPhone. This is what we always hear from our customers. They tell us, look, it's very simple, do it like an iPhone. But it's not so simple, of course. What does it mean like an iPhone? It is, again, intuitive gesture control. It is a fast and reliable activation of the control. But if you talk about, again, a control panel, you would maybe need on the surface a certain finger guidance, like, for example, a certain topography in the surface, or a backlight showing you where to touch, where do we have to activate the switch, and so on and so on. But also you would like to have feedback, means is this control now activated? So you can do this with an optical feedback through a backlight LED, but you could also think about additional acoustic feedback. People are always talking about haptic feedback, so they want to have something in the finger or on the finger to feel that this is activated. But we usually think that this should not be part of a control concept of a touch panel or touch console of a device like a washing machine. So if you translate, let's say, this control concept in some, let's say, elements or components, it will end up with some like 4 components, like a wheel, like a slider, maybe a switch, LEDs for the backlighting, and then you will have the whole system already available, or all the components available to make this system and to set up the system where you can do this, let's say, touch control of the washing machine. So again, you see, we want to motivate you to also discuss with us and also to maybe come up with some questions. Just again, online chat is one possibility, and also via email, or join us in our LinkedIn company page and follow us, and there you can post also some questions when necessary and when you want to have some more information about it. So let's go into the technology. We're talking about integrated setup of control consoles. On the left-hand side, you see the traditional setup of a control console, which shows a zillion of single parts. You have the bezel, so the front part, which is a plastic part. You see all the light guides. You see some mechanical molded parts. You see PCBs. You see LEDs, all stuff, components, wiring, cabling, and so on and so on. This is the traditional and, of course, not so bad setup of a control console, but we think it is time to have something more integrated. So something which is, in the sense of smart plastics, an integration of electronics and plastics in one single part. So in an ideal setup, you could imagine to have really one molded part as a control console plus the PCB, which gives you the whole system and which replaces the zillion of single parts which you have on the left-hand side. So what are the benefits of an integrated setup? And I just want to highlight 2 topics, let's say, on that. One is the stability. You have, as I mentioned already, less individual parts. This means you have less interfaces and therefore simply less prone to failure. You have, behind the production of an integrated setup, you have a highly automated production process with a high yield and with no manual assembly, means this can be controlled in a very good way. You have a compact layer stack. You have no moving parts. You have no air gap, which is especially very important for touch controls. Because as we all know, the air gap does a lot of, let's say, failure in your control panel due to the air and the different, let's say, resistance of the air between your finger and the sensor itself. What you also have, and what also brings a positive impact to your stability, is a closed surface. The closed surface, not only from the A side, so let's say from the side where you can touch the console, but also from the back side, from the B side, you could have a closed surface. And this brings you a high protection against dust, humidity, or other, let's say, environmental influences. And then the second benefit, I would say, is the form factor and the design factor. You can do complex 3D forms which are usually not possible or very limited only with a traditional setup. You can implement very touch-friendly surfaces, and you have especially a very thin design height. So control panels with the overall design height of 2.5, 3, up to 5 millimeters are possible with integrated setup, and they are not possible with a traditional setup actually. So I would like to mention that we have, I would say, two main technologies for the production of integrated control consoles. One is a well-known technology, MID, molded interconnect devices. And the other one is an in-mold plastic film. The MID concept, in the MID concept, the conductive structures are processed directly on or into the molded part. So first you mold the part, and then you do some treatment that you directly embed the conductive structures on the molded part or into the molded part. Two, let's say, standard techniques here are, for example, 3D mounting, for example, 2K injection molding or LPKF LDS process. The aspect is that after you have this, let's say, molded part with your conductive structures, you have to 3D mount electric components if you need them. In the in-molded plastic film concept, you do the whole processing on a plastic film. Afterwards, you do the forming and the in-molding. An example for that would be the multi-skin film of a technology that our company developed and is offering. So I would claim now at this webinar that there are a lot of benefits using plastic films when it comes to integrated control consoles. And I just want to highlight some of them. One is that decor and function layers can be on one plastic film. So finally, you need one plastic film to integrate the decor and the functions. If you are working with a plastic film, then you see that the processing of the decor conductive structures and the mounting of the components can all be done on a flat substrate, which is a big benefit in comparison with the MID technology, where you have to do a 3D mounting of the components. So as long as you're on a flat, you're more or less on a standard process, and you're much cheaper for the process costs, like in MID technology, for example. You have a certain flexibility in the further processing. It is not said that you have to in-mold process the final film. You can form it, you do not have to form it. You can use the unformed film. You can do something like, for example, back foaming, so not molding, but foaming the film. And in some application, it's even possible to use a plastic film already as an integrated control panel. So just imagine you have a plastic film with a thickness of 1.5 or 2 millimeters, which is already stable itself. And then you could even think about using this only the, let's say, formed plastic film as an integrated control panel. So I just would like to go a little bit into detail regarding the materials used. First of all, the plastic films. And I just picked out some interesting, let's say, candidates for substrates. PET pen films, which are polyester films, PC, liquid crystal polymers, and polyimide. Polyimide is highly or often used in electronics industry. The PET, pen, and PC substrates are more from the plastics industry, let's say. Liquid crystal polymer, due to the costs, is, you will not so often find. And this already shows one point, and the, let's say, line on the bottom, the costs. You see that the polyester candidates are relatively cheap compared with the candidates like polyimide or liquid crystal polymer. On the other side, let's take a look at the top lines, which are dealing with the temperature. You have a certain glass transition temperature, GT, which is a very important indicator when it comes to forming. You have a melting temperature, which is also something which has to do or is interesting in terms of forming, but also in terms of further processing. So if you want to, for example, reflow solder, I think a PC would not be the right choice in this case. Shrinkage is also something where you have to take a look at. And so you can choose the right candidate for your application out of several plastic films. And there are only some examples here in this slide. So next you would like to do or to process the conductive structures. I again picked out the most common materials: printed silver, copper in a thin layer, so below 1 micrometer, copper in a thick layer, which is, let's say, around 35 micrometer or below 35 micrometer. Everything what is above 35 micrometer is maybe not so feasible on a foil anymore. ITO, P.PSS, and just to make sure that this is also mentioned here in this context is the LDS LPKF copper. And if you take a look at the, let's say, materials used here, you see the copper, of course, is very good in terms of conductivity. But usually it is not possible to form, for example, a thick copper layer. Therefore, you would go maybe for a thin copper layer where the conductivity is not so high and you cannot, let's say, drive high currents. Silver is, let's say, a kind of compromise in this case. There are silver where you can also, which you can also form, but usually silver is not formable, but it has a rather good conductivity, so this is a good candidate. One thing I want to mention as well is maybe the last line, the material transparency. So if you want to have a transparent conductive film, then you must probably choose ITO coating. ITO is a, let's say, very expensive and very brittle material, so you cannot form it at all. You cannot even handle the substrate as a film. This is a disadvantage, but it has a rather good conductivity and it is perfectly transparent. All the other candidates from the material standpoint, like silver and copper, are not transparent. P.PSS is a polymer which is transparent. It has a somehow bluish color, but it is transparent. But all the other parameters are not so good for P.PSS, so it is not so much used finally. So now we have our substrate materials. We have the conductive structures on the substrate materials. Next is we want to mount some LEDs, maybe a connector, passive components, even active components are possible. So this is more or less a standard process. You're usually putting your film on a rigid carrier substrate, and then you present the components via pick and place. So it's a sheet process, pick and place. There are some, let's say, first R&D results also regarding some roll-to-roll processing for the presentation of chips, especially, of course, thin chips. But this is still in an R&D phase, and I think the state-of-the-art actually is the sheet process. And then finally you have to connect somehow the components to your conductive structures, which is usually done with conductive gluing, so using a conductive glue, but also selective soldering is possible. For some films also standard reflow soldering is possible if you think about polyimide. But a lot of films do not want to see this high temperatures, therefore selective soldering is most probably the option. So if you have now your plastic film, then you can further process it in the way that you go. For example, for a high pressure forming, which gives a very high accuracy and is, let's say, very feasible, especially for conductive structures. And then you can go for molding. And as I already explained, you could maybe only take a formed film as a control panel, or you can even skip the forming and make only a flat panel, which is also an option for an integrated control panel. So I just want to make a small cost breakdown, and it's very generic. It's nothing very special. It's just to see where we could end up with a concept like this. And you can see, first of all, there is a from to, and this is a very, very wide range between €5.30 for the from and €16.90 to the to. So this is something which, of course, is just to give a hint and just to discuss in this direction a little bit. So the assumption is that we have a console which is, let's say, a typical washing machine console, around 600 over 100 millimeter, and with a, let's say, production of 250 units per year. And so you would end up with maybe cost for the plastic film, depending on the substrate you want to use, from 5 cents up to 30 cents. Conductive structures will add another 60 cents up to €1.30. Then the big differences start, but this is just due to the number of, for example, LEDs. If you want to mount only, let's say, 10 LEDs, you will end up maybe with a 90 cent. If you really have a very complex control panel, then also €4 will be possible. Same applies for the decor layers. If you want to only make a white decor layer, you will maybe have to calculate with around 50 cents. But there are also very high level decors, usually then metallic decors, which is maybe €4.50 or something like that. And then you will have to form and maybe to cut, or to cut in any case and to form maybe the film. This is something between €35 only for cutting and, let's say, slightly forming, and €2.50 when it comes to let's say, more complex 3D structure. Also, the molding depends on materials, depends on the form, on the cycle times, and I put it here €1.20 to €2. And then finally you have to think about the electronics. I put it on the 0.7 BCB, which is maybe €1.70, maybe €2.30. This finalizes this cost breakdown, and this is something which is just an approach, and is something which can be discussed, and any input in this case is appreciated. Again, this hint for the questions, please take active part of our webinar and post some questions, especially because we are now coming to the end of the webinar. I just want to introduce briefly my company and our technology that we are using in-house. Plastic Electronic is a small, highly specialized Austrian technology company. We are developing and producing exactly that, what I'm talking about, integrated control consoles, usually for, let's say, 3 or 4 market segments. One is, of course, home appliance, one is automotive, another market is medical devices, and of course we're using a special plastic film technology, the so-called multi-skin technology. And multi-skin technology is film technology that integrates electronic functions and decor on one plastic film. So electronic function plus decor is the multi-skin film. And the multi-skin film is an insert that is ready for back injection or overmolding, and can also be formed. So this is something which is possible with this kind of films, and this means this multi-skin technology is pretty much what I explained before. There are several details with that, so if you are interested in details, please ask or please send us an email, then I will be happy to answer that. Multi-skin films are multi-layer plastic films, so there is sometimes the idea that this would be one film with one layer. This is not the case. This multi-skin films are tailor-made for each customer, so this is not something where I can send up, for example, send out a sample. This is really from project to project. We have to think about the concept of the multi-skin film, and it is a multi-layer, can be even a laminate of different films, and you usually have typical interface layers who are there for protection, are there for adhesion, are there for making the interface to another material. You have the decor layers. This is usually not only one layer, there's also more layers, and of course, as I mentioned before, also the functional layers. All these layers on one plastic film and called the multi-skin film. So, ladies and gentlemen, thank you for your attention. I hope you enjoyed and it was interesting for you, and I'm looking forward to your questions.
Thank you for this presentation. So far, 2 questions were asked. The first one is if there's any experience with wet fingers on the surface.
Yeah, this is a very good question, of course. Each kind of water or liquid influences the touch field, and therefore I have to say yes, there is an effect, but I think this is like with also other effects which take place in touch sensing. There are ways to control this. There are ways in the software. There are ways in the electronics, but there are also ways in the surface. There are also ways in the 3D form to make sure that the water or the liquid does not influence the capacitive touch, that it comes to, let's say, unforeseen activations or things like that. This is, but it is a topic, and it has to be taken in account for every development of a touch console.
And the second question that was asked so far is, what about multi-touch?
In principle, this is possible, but a multi-touch is a concept which is from, depends a little bit in which direction this question goes. So I had something in mind, but I'm not sure if this is exactly what the person who asked the question wanted to know. When it comes to our multi-skin technologies or multi-skin films, we are usually doing let's say, kind of structures like a wheel slider and simple buttons. And this is not comparable. So this is not a multi-touch solution, finally. There are multi-touch solutions on plastic films. This is, of course, possible. This depends only on the sensor design and on the electronics behind. This can be, but our multi-skin technology does not provide multi-touch.
I hope this answered your question, Ms. Stadlober, and if not, you can just type in again in the chat if it was not sufficiently answered. And any more questions, we are very happy to answer. I will just wait for a couple of minutes and see if any questions occur.
Maybe not a couple of minutes, you know, waiting a couple of minutes is quite a long time. Rather a couple of seconds.
Okay, but if not, that means that most topics are clear, which is a good thing. Again, the reminder, we will send you the presentation and the link to see the full webinar in a couple of days. So you can see it again, and if then maybe questions occur, you can also just email us and we will try to answer your questions. So, but I see that no one else is typing in a question. So I think we can close the webinar. What do you say?
Yes, I would like to thank you, Bianca, for your moderation, and thank all the participants for being part of our webinar about integrated control consoles. Thank you very much.